Hello friends. So today we are going to work today on multi-level classification on packing dataset. Okay. So now let me show you guys about this. On the packing dataset, if you look at this is video. On this video, we have what there are places where it is open for packing and there are places where it is occupied. So we need now to locate now the area where they are open and area where they are closed. Okay, so we need to use our machine to detect the area where it is open and the area where it is closed. So for that light, we have come out now with what the data. This is the data contain what various videos and model. This is data. You have empty data and you have not empty data. Okay, empty data is at the point where the data there is nothing there. If you open at this point, this is empty data. If you click on it, there is nothing there. There is nothing. Okay. Then also for not empty data, if you click on not empty data, if you look at it, we realize that we are going to see vehicle because it is a parking space of vehicle. Before you want to become a machine learning engineer, you must also know on how to work on data that vehicle how to park. You know these self-driving cars, they always park without any stress. This is what helped them to do that by using of machine learning. So this is the data that can do that work. Okay. Now let us now move forward into business. Okay, for us to do that, what are we going to do? We have to import OS. Import OS. OS, what is the OS now is for to help us now to locate where precisely our data, because look at this is our data, right? So it is inside empty and not empty. So I want OS now to locate me this direction where it is. Okay, copy it, copy it. You go now to input directory equals to, okay, then you paste it there. When you paste it there, if it's okay, you run it. Okay, when you run it, the next stage now is the data category. But before we do that, we have to check input directory path. Okay, let us ask we have import OS to list us the directory by saying os.list directory. So this is our directory. You copy the directory, you paste the directory, you run. You see, this is our directory. OS is telling us that our directory is empty and not empty. Okay, so we have empty and not empty. So when we have this now, we move to what category. So we are able to name the category. So we just copy. This is a category. Let's copy here and put it here. This is a category. You run it. When you run the category, then from there you create data empty list. Okay, data, they create data and label. Okay, label also empty list. You run it. When you do that, then the next option, so we have to iterate through the image. Okay, for us to iterate through the image, we have to write this code for category. For category index, category index, comma, category in enumerate category enumerate category. Enter, then you say okay, and then you make category, you say okay, for file in what os dot list the directory. Now list the directory for file in os dot list the directory os dot path, the path of the directory, dot then join. Okay, then we have now what are we joining? We are joining now the input directory. Copy it here, come here and paste. Are we there? We're joining the input directory, copy and come and paste, comma, then we join again what the category, copy here. Okay, category, this category. Okay, category. Okay, category. Okay, now we have joined input directory and category. Can you place this? Continue. Now, after we move forward on what we have to now create image path. Okay, image path, and creating image path is equal image path is equals what? os dot path dot join, os dot path dot join. What are we joining? The input directory, category. So to create the image path, we have this, copy this, paste it here, comma, then place file. Okay, then when you do that, now we have to do what? We have to read the image path that we have joined. We have to read the image path. Image is equals to what? We have to read to read. Now we have im read. We are going to import it out there later. Im reads, that's image read. img path, the img, this one img path. Okay, say image, want to read this part. Okay, so when we have that, we have to resize the image. We call image equals to resize, sorry, resize, resize image. Now we resize it on what? By 15 by 15. Then resize 15 by comma 15. Okay, after we resize, what do we do next? We have data. We flatten the image by calling what? Flatten the image and store in data dot append. Flatten the image and store in data dot append image dot flatten. Okay, flatten the image and store in data. Okay, now when we do that, that is for data. We go also for label dot append. Okay, because since we have label, we have here, it was empty data and label, right? So now we flatten the image and store in data, and also on label also append category index. Okay, label append, okay, category index category index. We have all those. Now after doing that, we have done that, I run the data. I realize that on line 4 we have image im read path. They say what? Because our machine has read line 1, line 2, line 3, arrive at line 4, so that there's an error there. So you see the name im read is not defined. Try to off the video and guess what is wrong there. Okay, thank you very much. Hope you have understood what is wrong there. Now come back this way. Since we import only OS, we have to do what? To say from sk image, image.io import im read. Okay, then in addition to that, we also need to do what? Import also resize also. If not, we have the same error also. Okay, so we say what? From sk in from sk image, sk image dot transformer input resize. Okay, now our next option, now we have to do what? We have to fit the list into numpy array. Okay, we have to fit the list into numpy array. Okay, fit the list into numpy array. So by doing that, we have to import numpy array as np. Come always like to fit the import numpy array as N NP. Okay, when you do that, we want it is an invalid sentence import number array as NP. Okay, we move. We don't need to put the array there. Okay, we want it. It's okay. So now fit the list. So we have to do what we call data. Since we have what we have data and label. Okay, so we're going to call data and label. Data is equals to fit it equals to NP dot fit into what array. NP dot array fit the data. Okay, data. Then we have what label. Label is equals to np dot array do what fit the label. Okay, so when we do that, we run it. When we run it, what next? We split the data into train and test set. Okay, split the data into train and test set. Okay, so now for us to do that, we have to also come back here and import something here. We say what from sk link dot model selection. sk link dot model selection import chain test split. Okay, when you do that, we want it scaling the model import chain test split. When you import the chain test split, now you have now to come down now. Now what our chain test split, you have x x x chain sorry x chain comma x test x chain comma x test. Okay, then we have y chain comma y test. Okay, is equals to how the is equals to just copy this one chain test split, paste it here, and paste it here, open the bracket on what data comma labels comma test size equals to our test size will be 0.2. That's what 20%. Okay, I'll explain all later. Shuffle, I'll explain this all later. Shuffle is equals to true. Make sure that it should be capital T. Shuffle equals to true, and also we have stratified there, comma stratified is equals to levels. Okay, so now let me explain this section. Okay, look at on stratified. You can go on Google stratified in machine learning. Okay, so stratified sampling is a type of sampling method that aims to preserve what the proportion of a different category or the classes or in original data. Okay, for example, if you have a data set with 60% male and 40% female. Now let's see, 60% male. Okay, now I've not completed this one. That's unclassified. Then what about shuffle? On shuffle, you see, on shuffle data, it is a sample yet a powerful technique to ensure that what machine learning model train and evaluate the effectiveness by what randomly rearrange what the data point randomly. Okay, randomly rearrange the data point. So you can avoid what our objective is to avoid bias and improve generalization and make your model more robust. Okay, so those are the objectives that we place those things. Then also I mentioned about this the test size 20% because we have to test our model using 20% data. Okay, then we have to train with 80%. If you now I ask you guys to watch this my videos on pandas, you will learn more about that because I cannot be explaining everything. These are my videos. This is my mark. When you see this mark green of, you see my face there. This is index operation in pandas Python lesson 37, 36. Okay, you have this is it again. This is it again. Okay, so don't forget to watch. There are so many. Okay, let's go back to business. Now let's run our run. What are they saying? Called an unexpected unknown argument classified. Let's check what we have not spelled it well. Let's see. Okay, so we did not spell it well. We omitted S. Okay, S. The good news is that when you omitted anything, the machine is telling you, okay, run it back. Okay, that's great. That's good news. Let us continue. We need to do what? We need to train our classifier. Okay, train classifier. Okay, in order for us to train our classifier, we have to do what? To import. Come here. That is why. Okay, we say that word from scaling dot model scaling the model selection model selection scaling the model selection input create, excuse me, input what? Create search. Make sure this will be capital letter. Create search. Okay, then we have again what? From scaling dot svm input svc. Okay, so in search we have cv capital letter. Okay, so we have to train this classifier by doing what? By calling classifier as let's see fire is equals to what? svc. Okay, so in a nutshell, we can lightly see, look at, okay, this is standard scalar. Let me open the classifier. Yes, let me take you guys move along the classifier. Okay, now for us to come here, this is the link scaling to upper, or you type classifier SVC. Okay. Now at this point, SVC classifier SVC, when you type classifier SVC, you will have this. Okay, this is the scaling SVM dot SVC. So at this section, we have four classifiers. There are four of them. 1, 2, 3, 4. Okay, these are their parameters. The parameters 1, 2, 3, 4. So we are going to use just two parameters. This one C and the parameters of gamma. Okay, those are the two parameters. So in the next slide, you can still use this one or this one. Okay, but I'm going to use these two. Okay, so you can read all. They say this is, if you read on this one, say regularization parameters. Okay, the strength of this regulation is inverse, so you can read all. So let us go back to business. Okay, so classifier SVC. So I try to explain that because you should know why we are using this. Okay, so now we have what parameters. The parameters, that parameter that I just from show you now, and I say that we are going to use gamma. We use gamma. We use gamma. Yeah. Sure, it should be in string. We use gamma. Okay. Gamma, and on gamma we are going to label 0.000 so 01. Sorry, what happened? Let me put 0.001, put 0.0001, comma, then we put 0.00001. Yeah, then also we go to C as capital letter, capital C. C, we have 1, 100, 1000, 10,000, 10,000. So we have 1, 2, 3, 1, 2, 3, 4. So with this parameter, it indicates that what, that we are going to train 12 image classifier. How do we manage to have that 12 image classifier? Look at, we have here 1, 2, 3, and here we have 4. So 4 times 3 is 12. Okay, so we are going to use train 12 image classifier. Okay, that we are going to choose the best grid cells. Choose grid cells. Okay, now we see the word grid research.feed feed x train y train. x train, comma y train. Okay. Okay, before we choose the grid search, let us define the grid search in set here. I want us to define the grid search before running this. I want to define this grid search. We have grid search is equals to, excuse me, grid search is equals to, we have grid search CV grid search CV. We have classifier, sorry, classifier, comma, and parameter. Okay, so we have classifier and parameters. Okay, parameter. We have to do what? We have to test the parameters. Are we there? We have to test the parameter, and for us to test the parameter, we have to choose. That's the best. Choose the best estimator. Best estimator. Best estimator. Choose the best estimator is equals to what? We have grid search dot best. Okay. Grid search dot best estimator. Make sure, okay, make sure you finish it with this. If this is not there, you're going to have error. Okay, this indentation must be there. Okay, so we have to, the next step is that we have to import accuracy. Okay, so for us to import accuracy, let's come here and fit okay, say from scaling dot metric import accuracy accuracy score. Yeah, now we do what? We write y predict or y prediction. Okay, y prediction is equals to what? Best estimator dot predict x test predict x test. X test. So on this y predict, you see equals to best. We call this best estimator, bring it here, dot predict x test. So when we do that, we look now for score. That score is equals to what? Accuracy score. Accuracy score. Now on accuracy score, now we have y predict, prediction, y prediction, comma, y test. This is y, you copy this y predict and feed here. Okay, and now we work on what y test. Okay. Okay, now let us see our score. Okay, see our score 0.9999. Are we there? Obviously shown that our score is very good. Okay, then let us now work on what. Let's print. The score is very good. Is we can end here for today. With this score, you can use pk dot to save the file. But this video has been so long, so we have to end it for today. Okay, so our score is very good. Okay, very perfect. We can store this data, score it using pk. So in the next lesson, I'm going to show you guys on how we are going to store this. I want to learn this video. Okay, now let us to recap. What have we done? We work on what? Multilabel classification on what? Packing data. Okay, these are, we have import OS. We have what? We have these are the various things that we have done. We have what? Import directory. This is where that file was there. Then also at this point we have what? Empty and not empty file. The category of the file was what? This is the category. We create an empty list, data and label. We iterate over the various image and the label. When we did that, we did what? We create what? We feed the list into the number array. Then we split the data into the chain and test set. Then we chain the classifier. We call classifier SVC. Then we work on what? On two parameters. The parameters are what? We work on gamma and on C. And obviously we use what? There are 1, 2, 3. There are 12 of them. That means 3 times 4 are 12. Then we go on what? Grid search. What we call grid search. We choose the grid search. We feed the chain and the test set. When we did that, you will see this on Jupyter Notebook. This is always there. When you run it, you will see this. After that, we test the parameters on what? Best estimator, grid search. We do what? We input the accuracy by calling what? Y predict best estimator on what? X test. Then we score the accuracy. Okay, and we look at the score. If the score is close to 1, is very good. Okay, when your score is below let's say below 6, below 6 is very poor. It's not good. 6, 5, 5 is the worst. Okay, but when it's close to 1 is the best. Are we together? Okay, take care. If you find this video useful, please subscribe to this channel and you continue to watch something like this. Okay, take care. Make sure you like, and if there's any comment, you comment below. I'm going to answer you. Bye bye. Yeah, may you choose me for the view. It's already midnight in China, so it's not possible for you to see my image well. Don't bother. It's just that today I was supposed to finish this video. That was the reason that I need to work this video at this time of the day. Okay, take care. Bye.